week, adding and subtracting, multiplying and dividing, and solving rational expressions. And now we're going to start a little path of graphing them. And so there's some terminology that we need to learn. First one being is asymptote. Anybody want to look that up, or do you know what that is? Grab your device and look up asymptote. Tell me what you learned. You guys are all waiting for each other. Clayton picked up his phone. He's my favorite right now. Abby picked up her phone. She's my other favorite right now. Yes, ma'am, what'd you get?
Oh, I don't know.
I got a line that continually approaches a given curve that does not meet it at any distance.
Okay, so a line that a curve approaches?
Continually approaches.
Okay, I like that. A line that a curve continually approaches. So that doesn't necessarily help you much yet. But the line that our function will approach and get closer and closer and closer to, and I'll show you what I mean here in just a second.
I remember these.
You do remember these?
They might be done, but yeah.
No.
You have? You've done these? Something that looks like this? Absolutely not. I haven't taught it to you, but I'm going to now. I was going to be really impressed if Mr. Glacier gave those to you last year. Okay, so what makes a horizontal asymptote? So that means this direction, right? At y equals 0. Go ahead. That's if we have, actually don't put constant. Erase it. That's what we're doing today, but my whiteout's over there. If we have a smaller degree in the numerator than we do in the denominator. Do you remember how to find the degree of a function?
No.
No. All right, so let's do a little review. If I have x cubed plus 2x minus 5, guess what its degree is? 3. If I have x squared plus 5x minus 1, guess what its degree is? 2. If I have x minus 5, what's its degree?
1.
1. If I have 6, what's its degree?
1.
You are doing so well. 3, 2, 1, 0. It would have a degree of 0 in that case. So our functions today, the
So
only
it has to
ones...
be the exponent of the variable?
Our functions today are all going to be constants over linear. I'm not going to be too crazy with you today. And so what's the degree of the numerator here? 0. What's the degree of my denominator? 1, right? Just the exponent, 1. So because this degree is smaller than the denominator, I know I have a horizontal asymptote. I'm just going to abbreviate that with HA at y equals 0. So we can have horizontal asymptotes, we can have vertical asymptotes, we can have oblique asymptotes. We've got some crazy stuff that we can do with rational functions, and we'll build with it one thing at a time. What can we not divide by? 0. You're right. I can't divide by 0. Because I have a variable in the denominator, that means there's something x can't equal. You guys are good at this game.
No, just 5.
Yep, x cannot equal 5, so that means we have a vertical asymptote at x equals 5. We'll practice graphing these in just a second. Right now we'll just figure out how to calculate them. The function below it. I have a horizontal asymptote at y equals 0. Tell me why. Smaller degree on top than I have on the bottom, right? And then my vertical asymptote, where does my denominator equal 0? If you don't like to do that in your head, remember all we're doing is setting that equal to 0, move the x and then divide. So vertical asymptote at x equals -2. All right, so over here are the steps to graphing these. First thing we'll do is find the asymptotes. And you're going to discover that that splits our graph into a couple of sections. So I'll show you what I mean. Now let's stick with pink. Where is our horizontal asymptote on this function?
0.
Good. Y equals 0. The y equals 0 line is right there. And we note asymptotes as a dashed line because they're really not part of our function. Okay, and we have a vertical asymptote at x equals -4. Yeah, -4. So I'm going to graph that. Dashed line, just like we did that horizontal asymptote. Now, what I need you to see is that we've got a left-hand side of our function here, and we also have a right-hand side. We kind of split it from that vertical asymptote. It's kind of hard for you to see through the camera there. So I'll make that a little bit bigger. You'll find that the graphing software that you use today will make this extremely easy, but you've got to do a little math before you can just click graph me. So what I'm going to do is I'm going to plot points in both sections of my graph, on the left and on the right. So that's where we are right here. Plot 2 to 3 points in each section. And we are just going to plot points by creating a table. You might get ugly values. Do you remember how to plot ugly values in ALEKS? Remember there's that little square that you click it and then you insert the point? Okay, so we need to pick x values that are to the left of your vertical asymptote. So if this was -4, maybe we're going to choose to plug in -5 and -6. ALEKS is only going to make you plot 2 points in each section, so that's what we're going to do right now. If we were graphing by hand for the whole way, sometimes you need more than 2 points to really see what it looks like. Help me out. Plug in -5. Maybe we need some scratch paper here. 4 over x minus a -5 minus 4. 5 minus 4 is 1. 4 divided by 1 is 4. All right, let's plug in 6 now. 4 over minus a -6 minus 4 gives me 4 over 2, which is 2. All right, so let's plot those points. -5, 1, 2, 3, 4, -6, and 2. Now these don't create a straight line. It's not a linear equation. What happens, those asymptotes are my guides. My curve gets closer and closer and closer to them, and then turns and goes along it. And ALEKS will do that for you. After you have points on both sides, you're just going to be able to, say, connect the dots. And do you remember when we had something connect the dots and it goes all over so you know you did something wrong? That will happen in this section too. Pick numbers on this side that might make your math easy. I think 0 is a great one. 1 would be a good one. Sometimes I don't like fractions. I might choose 2. I might choose 4. It just kind of depends. Do you guys want to go with 1, 2, 4?
2.
All right, I'm hearing more twos. We're going to go twos. Okay, so if I plug in 0, what do I get? -1. And if I plug in 2, -2 minus 4, I get 4 over -6, which is -2/3. All right, so at 0 we were -1, and at 2 we are at -2/3. You know that represents a curve. You know that it approaches those asymptotes. In your homework today, you're just going to click the button, and it will graph that for you. Let's do another one. Do you need a second to finish up? Looks like maybe. All right, let's follow our steps for the next problem. Vertical asymptote. Where? Ooh, sorry. You guys are used to me saying horizontal asymptote first. Horizontal asymptote is at y = 0. My vertical asymptote is where? What makes that denominator equal 0? It's the same denominator as the one we had before. All right, so that's going to be -4 again. Lord, I can't see that. All right. Let's pick the same values then, shall we? X and Y, -5 and -6. On this side, you guys liked 0 and 2. Has somebody already plugged in -5 for me? I heard it. Yep. And then if we plug in -6, 6 minus 4 is 2. 6 divided by 2 is 3. All right, so at -5 it was 1, 2, 3, 4, 5, 6. At -6 it's 3. And now it's going to approach those asymptotes and get closer and closer and closer and turn as it gets closer. Okay, let's plug in 0. Substitute it in. 6 divided by -4 is -3/2, -1.5, however you like to think about it. Substitute in 2. -2 minus 4 is -6. 6 divided by -6 is -1. So 0 and 2 at -1. Can you eyeball what that curve will look like without my help? How is the second function that we graphed different than the first? I know you're going to tell me the 6 is different than the 4, but what did it do to your image? What did it do to the graph?
It made it farther away from the lines.
Yeah, I liked how Hannah, she took her hands and she went like this, and your words mimic what she did. It stretched those points higher, didn't it? So it stretched our function. I like it. All right, let's do one more. Why not? All right, I'm going to say the one you're used to me saying first. Horizontal asymptote, where is it? All right, at y equals 0. My vertical asymptote is where? Good. Plot those. Okay. What points do you guys want to use on the left-hand side? I might choose 0. Yeah, I like 0. And what? -2?
Yeah.
All right, when we substitute in 0, we get -1. And when we substitute in -2, 2 divided by -4 is -1. So 0 was -1. 2 is -1. Eyeball that curve. And what would you like to choose for our x values on the right-hand side?
3 and 4.
All right, she has spoken. 3 minus 2 is 1. 2 divided by 1 is 2. I'm glad you picked 4. That's nice. 4 minus 2 is 2. 2 divided by 2 is 1. So 3 it was. 2 at 4 it is 1. How do you guys feel about this? Because you're pretty quiet. Needs a little practice, maybe? Seems easier than what we've been doing? This beats solving for x in rational equations? All right, let's get after it then.